So let me introduce Jason Mars, who is our next speaker. So Jason is a professor at University of Michigan, and he's also the CEO of Clinc.com. And what I think is interesting about that startup is it's an ML startup, and they actually managed to build useful machine learning services without having access to the same amount of data that companies like Microsoft, Facebook, and Google basically have. So it will be interesting to hear how they managed to actually do that.
Awesome. Great to see you guys. Good morning. So I want you guys to feel free to ask questions throughout. You know, this is a great opportunity for us to have a dialogue, and I'm delighted to tell you about what we've been doing at Clinc in the last 2 years. I'm going to start with the story as to how this came about. And at any time, there's so much that you can cover when talking about the entrepreneurial pursuit from an academic platform that I want you guys to jump in. If you want to ask about licensing, if you want, just feel free to raise your hand at any time through this talk. So if you aren't familiar with us or our work, we're Lingjia Tang and I are professors at University of Michigan. We're also a two-body, and we've been on the pursuit of doing something interesting, important. Just as every academic in this room, or every researcher in this room, I should say, having impact has been our creed, and that is what led us through this journey to create Clinc and be able to have another platform in which to have impact. So how did it start? Well, so we have a group of, our group at University of Michigan grew to about 14 students. We wanted to work on the most important problems in the world, and we were always on this pursuit to find, the biggest weakness in technology and to bridge the gap to the future. And so we started in data centers. We started working on web search and Memcached and scale in general in data centers. We looked at all layers of the stack, from programming languages to compilers to microarchitecture across the entire software system stack to innovate and improve our ability to scale to millions and billions of queries and not consume 30 nuclear plants of power. And so we had an insight at one point. It was clear that deep learning and machine learning was on the trajectory of what applications would look like. However, from a research standpoint, we came to the realization that if we really wanted to understand the implications on a scale-out data center, on a large-scale, warehouse-scale computer, when running deep learning applications, when running end-to-end services that used AI on its critical path, we needed to have a workload, right? And so one of the works, we've had a number of thrusts in our group, in compilers and so forth, but one thrust that I think we've been able to have an interesting contribution with is with designing end-to-end workloads and then understanding how systems need to be re-architected to acknowledge the differences of these kinds of workloads. So many of you guys are familiar with perhaps this slide where I have a roadblock, the roadblock being, if I wanted to understand how to scale Siri, Cortana, Google Now queries to millions and billions of queries a second from the world, and I wanted to reason about what are the systems implications of it, I need to have a workload. So we actually went to Google and Apple and asked them, hey, can you give us your workload so we could study it? And it was a resounding, are you crazy? So we had to do a best effort to build out this end-to-end workload. And so we built Sirius. I'm not going to get into the details as to how this workload works. I strongly encourage that you look at the papers, but this is what kind of created the seed that would grow into our path since, right? So Sirius was interesting. We tried to create a voice and vision assistant so you can ask things like, how tall is this building with an image? And the end-to-end system would be able to recognize what's in the image using image classification, and then be able to understand the natural language question, and then be able to answer your query. It's an interesting workload that intermingled what was going on in the language space and what was going on in the computer vision space, and represented what you can find in the wild, right? So we used a lot of open source, the best open source packages that did, we use AlexNet and VGG for image classification. We used OpenEFRA, and we use some TensorFlow out-of-the-box models to build this end-to-end system. Now, this led to a lot of work. So there was the original series paper, which led to a number of interesting discoveries and contributions that we made. So all of these papers is on the thrust of intelligent assistance and future workloads. And this was great, but in the process of working on this work, you have to build your group up to have a deep understanding of machine learning, right? In order to build the right systems, especially when you consider specialization is what we're doing now as a computer architecture community, you have to understand what's going on. And so my students, myself, Lingjia, became very aware of the latest papers, 2016, 2017, ICML, NIPS papers, and we would take those models, re-implement them from scratch to make our processors faster and to reason about data movement between compute and memory and reason about scale. And in the midst of this, and let me just say, Sirius had a nice impact. So we're on this pursuit of impact, right? So we open source everything. We create a benchmark suite. There's been a number of folks in the community who've used this workload to study systems. We had a lot of press. There's folks all over the world that are contributing to the open source project and using it for various use cases. There's a police department in Australia that wanted to build a conversational system in the car, and that's interesting. They wanted to use Lucida to do that. But along this path and with reasoning about what was going on, what was possible with the latest research, we saw an opportunity to do something bigger. We wanted a platform where we can work on problems in a way that we know that we're affecting the real, the real problems in the wild and industry. And so in July 2015, the week my son was born, Zayden, we started Clinc. And we took a very unique approach. So typically, from an academic standpoint, when you start a company, that starts with an SBIR, a grant that you would then get, and then you would use that to kind of bootstrap a company. One observation I made was that pathway is not the best to build really amazing companies, right? When coming from an academic standpoint, and when you write a research grant, it's very different than if you talk to a venture capitalist, the ones that fund the biggest companies in the world. There's a different bar to scrutiny. There's a different level to the scrutiny. And so how we started was with conversations with venture capitalists. We had a vision to, Clinc 1.0 was a vision, and I'll talk about this in a couple slides. So let me just start with the co-founding team. So myself, Lingjia Tang, Johan Hoswal, and Mike Lorenzano started Clinc in 2015. So this is the co-founding team. When we begun, we were 4 or 5 people working tirelessly. We've now grown to 35 people, and we've headquartered in Ann Arbor, Michigan, and we have an office in San Francisco. And so it's been an interesting journey, and I'll tell you how we got there. But Clinc 1.0 was an idea where we would take this ecosystem. So Lucida slash Sirius, so Sirius was renamed to Lucida after Apple complained that Sirius was too close to Siri in a letter. That was kind of scary, but fun and educational. Lucida is essentially a platform for plugging in various AI modules and then creating workflows for those modules to work in. Now, being that our team was building out the end-to-end implementations of what was coming out of research in ICML and NIPS, we had an insight that we can help companies, startups all over the world, create fascinating, interesting experiences in their products by leveraging this platform, this ecosystem of AI engines that we were building out, right? So that was Clinc 1.0. This was good enough to get our Series Seed funding. And so we had a number of modules. We implemented a sentiment analysis that used LSTMs. We built out various QA systems, text summarization, used abstractive text summarization approach, deepface, implemented deepface for facial recognition, object recognition with a host of various models, AlexNet, VGG, which you could train. So we had all of these modules in this platform, and we were starting to grow the number of proprietary engines that we had in our system, and then would work with companies. And so we actually started working with a couple companies. But one key insight, there's a lot of startups that look like this, that have this business model. We have awesome AI, and we'll integrate it in all your products, right? Luminoso is a very successful case of this business model from MIT. However, this is a business model where you end up, we got some insights being on what I call VC Street and chatting with VCs, reasoning with them, building relationships, and evolving in that intellectual narrative of how do you build the right company that can scale. We realized that this isn't a scalable model. You end up becoming like, best case, an Oracle or an IBM, where you have to scale your consulting services. You're essentially a consulting organization, even though you have a proprietary software stack that you're using as a hammer to hit nails, right? You might look like a SAP or an IBM. And the challenge there is you have to scale the org as you scale the customers. So how do you get more scalable? If you look at Facebook, right, one dude could make a website. It wasn't really one dude, but you know what I mean. Like one guy or woman could make a website, and then that can scale to 1 billion users, and then you have a team of 10 people, right? That's how you build phenomenal companies, at least in this kind of tech ecosystem today. And so we were like, okay, that's what we need to do. We need to find one problem, a societal problem that touches everyone, and just hammer that problem with our technology, with our know-how, with our scalable systems. So eLab did our Series Seed. We did 1.2 million with Michigan eLab. It's based in San Fran and Michigan. Ann Arbor, they're probably, when it comes to seed rounds, the biggest seed round fund in Ann Arbor. So they led the seed. We also had Hyde Park Venture partners from Chicago in the round. They're very, very premier seed level Series A investors in this round. And then we were heads down stealth mode. We had a little bit of money in the bank, heads down stealth mode, and built out Fin8. This was the vision to connect people with their financial stories. So the one area, so when we were doing Sirius, right, we got a lot of interest from all kinds of verticals, right? Ford reached out. We're actually doing a sponsored research with them now. Wells Fargo reached out. We had a number of folks that came out, General Electric, and realized that the financial use case was particularly interesting. I mean, if you think about it, all of us have money, reason about money. Most of us have bank accounts. And understanding what's going on with your finances is a societal problem. If I asked anyone in this room how much you spent on your last vacation and how did it compare to the vacation before that, you guys would be hard-pressed to give me that answer, because it would take work, pain, agony to go look at your transactions. Even if you had like Mint, you'd still have to look at the last vacation, one before that, do some math, and that's a problem. And that's a problem we believe that we can solve with AI. So we built this out. We launched at Fin8, which was it's one of the conferences for in the financial fintech industry. We won Best of Show at this conference. One thing about AI companies, when they do shows and they pitch, they rarely let random people try their tech because it's usually brittle and it breaks. And so when we launched, we had a very high bar. It needed to work well enough for you to let a stranger come and talk to your intelligent assistant without any guidance, any training, any whatever. Just come and talk to this thing we built. And so we did that at Fin8, and it was phenomenal. So with that, we did our Series A. And we did the Series A, so Mark Kwame and Chris Olson are from Sequoia. They left Sequoia to create Drive Capital, which is the biggest fund in the Midwest. It's a $600 million fund. And Kwame did the Series A for LinkedIn. And he's on our board. We have a super clean board, 3 members, me, Ling Jia, and Mark Kwame. And it's been a very interesting journey. So he's been on the board. We got more money. We did a $6.3 million round. And that's been really, really good. We've scaled to 35 people, as I mentioned. We haven't burned as fast as you'd expect. We've done about $1 million in pilot deals with financial institutions and are working on our first master level agreement. The price points of these are in the 4 to 8 million range, depending on bank size. We're focusing on the top 10, top 15 banks right now. But I'll show you what we built. I know it seems like I'm kind of getting ahead of myself. Well, let me just tell you about how we reason about the philosophy of the company. There's a lot of AI companies in the world. However, AI companies talk about AI too much, right? They don't talk about problems. And so we focus on reducing complexity in humans' lives. That's it. Improving quality of life. That's it. That's our goal. Our goal isn't to do something interesting in AI. It's to solve a meaningful problem that hasn't been solved yet. So we take some research, training into the way we reason about products. And so what we ended up building is this stack for conversational AI that functions completely differently than most of what's in the market. And that is because, and I'll tell you some of our secret, that's because our system never knows what nouns, verbs, and adjectives are in your sentence, ever. There's no top-down heuristical white box NLP assumptions in the system. I mean, if you look at some of the deep learning contributions out there, it's deep learning to help you figure out what the nouns, verbs, adjectives are in a sentence. As soon as you do that, you've lost the battle, because then you have to specify to the system what the system can understand. And it's not actually learning. You're not taking advantage of the insight of data-driven black box approaches, right? And so we have an end-to-end philosophy that we never give this system any rules or keywords or synonyms or dictionaries or anything specified. It learns entirely in that neural network architecture. Indeed, if you think about the last 10 adjectives I said, you probably couldn't tell me what the last 10 adjectives I said if I gave you $1 million right now, right? And so that's the insight. The reason these systems are brittle is you can't capture the scope of human language with rules, right? With grammars, even. Because things are messy. We fix ourselves. There might be a random word that appears out of nowhere, or something will get mistranslated by your speech recognition. And if systems break because the rules break, you're out of luck. So that's a simplification. There's actually a number of distinct problems. By the way, to build something end-to-end with machine learning, it's a systems problem, right? Because you have to solve so many distinct, separate challenges and integrate that into a system that works end-to-end holistically as that is one entity, right? And so we actually architected a new way to reason about intents that I can get into more detail, not in this talk. Completely new way to reason about intents. If you have to teach someone the 1,000 intents your system understands, then no one will use that system, right? If it comes with a manual, right? It's not like a human in the room. So we've used a lot of different approaches, from recurrent neural networks, proper five deep recurrent neural networks, to recurrent CRFs all over our stack, conditional random fields. Right now, I'm in love with bidirectional LSTMs because what we're finding is it's the jack of all trades. So across those distinct problems that we solve, we like at least some aspect of the approach or the neural network layer to be that bidirectional LSTM, at least at the basic layer, and then you can have matching layers, et cetera. So we can talk more about the distinct problems. I don't want to give too much about exactly how our stack works, because it's quite unique. But focused keenly on a problem, the principle that makes us different, we want to have a transformational shift in these kinds of technologies. And what we're pursuing is unbounded understanding. That is, you can literally talk to the system like it's a human in the room, and it understands you as a human in the room. We believe it's a trust issue. The system has to trust. You have to be able to trust the system when you interact with it. And that'll lead to the transformative shift. We've had a lot of press. Forbes calls us the most advanced AI in the banking industry. Of course, our game plan, we sound like a fintech company to most people, but we're actually a tech company that's dominating vertical by vertical. So fintech first, healthcare next. Robotics is interesting, automotive is interesting. And it's really just how do we get in those markets and then repeat what we're doing in the fintech market. We'll talk about it. But there's a corny video that actually just was sent to me by Intel like 2 days ago, and I was like, let me just throw it in this talk. It's like 2 minutes, but this kind of is the latest video we've done, and Intel did it. They're gonna use it in their marketing stuff, right? So there's gonna be some plugs for Intel in here. They paid for the video, so why not? So check it out. Let me see, I don't know if the sound is gonna work, but there's a cameo in here by another professor that you guys might recognize. We started the company Clinc with the mission of using the best science and technology in artificial intelligence to solve real problems. We focused on connecting people to their financial stories. From that, in Clinc, we created Fin8, the financial genie. How much cash am I dropping on groceries in the last 3 months?
You spent about $1,190 from your accounts on supermarkets and groceries.
Fin8 is really designed to be a way to allow people to interact with their finances with natural language.
Most systems that folks have played with and that's available have rules as to how you should interact with it. And so if you diverge from those rules and say something it doesn't expect, it breaks. When you ask a natural, messy human question, I think I have a shoe problem. How much did I spend on that in the last 3 months? We want Fin8 to understand.
You are about $331 above your monthly budget to spend on clothing and accessories.
We leverage state-of-the-art techniques in machine learning and deep learning to create this experience. There's 2 phases to artificial intelligence. There's a training phase where you train the neural network architecture to learn, and then there's the inference.
Inference is the process of taking new examples that the system has never seen before and actually giving responses to things that have never been seen.
You need a beefy processor when you're doing inference. And so that's why we use an Intel Xeon processor. I know. It's answering questions every day. I feel like to enable that.
Ultimately, tools like Fin8 can result in behavior changes. You can actually understand what you're doing and actually edit your behavior and make positive improvements to your life.
Our collaboration with Intel is one that's been incredibly useful for getting our technology to run and work as well as it does today. Fin8 is a proof point that we can actually take this thing people are calling AI and solve a real problem with it. I didn't do this. This is yeah. So I thought it might be a nice summary before we jump into a demo. So I'll do a live demo here with you guys. You guys can get a sense of the kind of free-form capability system. Let me make sure I'm on Wi-Fi and it works. This is actually running on a server, EC2. I'm making a lot of plugs for companies today. But all right, let me just make sure it works. What's my spending?
You spent about $10,000 from your accounts over the last 3 months.
All right, I remember I was in California sometime over the last 2 years and I dropped a bunch of cash on food. How much was that?
You spent about $331 from your accounts on food and drink in California, which is 0.44% of your total spending over the last 2 years.
All right, what about in Ann Arbor?
You did not spend any money on food and drink in Ann Arbor, California over the last 2 years.
They must have pushed a new version.
All right. What about in the last 5 months? How much food did I buy in Ann Arbor?
You spent about $775 from your accounts on food and drink in Ann Arbor, which is 4.78% of your total spending over the last 5 months.
Cool. So what's my most expensive transactions on travel?
Here are the most expensive transactions on travel over the last 3 months in your 3 bank accounts.
There's a host of features.
So how's Microsoft doing in the market?
Oh.
Here are the stock prices for Microsoft Corporation over the last 3 months.
What's the latest news on Microsoft?
Here is the news for Microsoft Corporation over the last 3 months. The latest headline is 2 tech funds paying up to 7.1%, one to buy, one to sell.
Stock news. So let me just show one more example or so to kind of demonstrate the power of being able to capture multiple semantics from one utterance. So with many systems today, if you wanted to say, change your withdrawal limit, you'd have to say, I'd like to change my withdrawal limit. Okay, how much? $100. Okay, on which account? Checking. Okay, when do you want it to end? Oh, like next year. I can do that all in one shot, and the system will understand in messy ways. So I can say, I'd like to change my withdrawal limit, set it to $500, have it end next month, and do, okay.
Okay, the withdrawal limit is $500.
Okay.
What is the account to update?
Right, I was gonna say the account, but it stopped listening.
Update my checking account.
Let me confirm your withdrawal limit request. I have the account to update to be your checking account and the withdrawal limit to be $500. Is this?
Actually, I changed my mind. Could you set the limit to $2,000, have it end next year, and yeah, that's good.
Let me confirm your withdrawal limit request. I have the account to update to be your checking account, the withdrawal limit to be $2,000, and the end date to be January 1st, 2018. Is this correct?
Yep, that sounds good.
Okay, I've completed your withdrawal limit request.
Now remember, this is a system. Oh, I forgot my favorite query. One more.
I'd like to take my friend to dinner. Can I drop $500 on that?
Based on your spending habits, it is not advisable to spend $500 on restaurants.
Yeah.
You would be 162.08% above your average monthly spending. This would reduce your balance to about $38,000.
And remember, this system has not had a single hard-coded anything in it in terms of rules or dictionaries or grammars, etc., synonyms, keywords. We use embeddings, of course, right? That's how we're able to get that. Everything goes to a multidimensional number. And then those numbers are all that's used to train all of our neural networks in the system. All right, not a big secret. But yeah, notice I mentioned dinner, and it understood I'm talking about restaurants. Like, that's not hard-coded anywhere in the system. It's just learning from experience. How do we do it? We build a bootstrap data set from crowdsourcing, right? And so we say if you had an AI in your bank account, what would you ask it? And that gives us that raw data set that we then curate and polish and turn into these training bootstrap data sets. And then you can collect more data from deployments. So we're rolling out into production January 30th at USAA in a 10,000 customer pilot. They're giving away Alexas and stuff. So this tech, actually, we bypass the Alexa stack, and utterances come to our AI in the cloud, our natural language understanding, and everything happens in that instance, and then the response is sent to Alexa. We've integrated on Google Home, Facebook Messenger, iOS native, I can show you guys that later, multiple touch points. And I'll just end off with just our story. Where are we heading, right? So we talked about financial institutions, banks. There's other verticals we can expand into. This is an old slide from the pitch. I don't want to do any of these other verticals because they're too boring. Healthcare is next, and then we're going to go into robotics and automotive. Interacting with your robot using natural, messy language. That market is one market we're interested in. VR, AR, when you're in those experiences, you don't want to be fiddling with your environment. Sometimes you just want to articulate what you'd like to do. Automotive is hot. We probably could get into that one before healthcare, but healthcare is really compelling for us. So with that, I don't know how I'm doing on time, but with that, I'm happy to take any questions you guys have. Great, great. Go ahead.
Tell me about privacy. So you've got banking data. Who owns the financial transaction data? Is that run in the bank? You guys are filling slots to send queries to the bank? Where is all that coming from?
Great question. And we get that from every customer as well. So, oh, sorry. So the question was, what's going on with privacy? What's going on with the data? How is the data being accessed? Who has the data? Who has control over the data? This is financial data. It's pretty sensitive. So in the cloud, so we have, of course, our SaaS instance, our SaaS model, software as a service model. And we never keep any PI data, personally identifiable data. We never keep names or social security numbers or anything weird, phone numbers in our, nothing's cached or saved in our system. Except we do keep the transactions. So we just keep the raw transactions, and we use that for a number of analytics that we do in the system. And then every user has a user ID. That's in the SaaS model. There's a lot more flexibility in our on-prem deployment. So with USAA, we've taken the whole stack. You know, we've built the stack end to end. So we've taken the whole stack and it's Dockerized, containerized. We deploy it behind their firewall, and then they can decide what they want to do with the data. We also have knobs for flushing the cache. Of course, we use memcached, and we currently are using MySQL as a backing store. Don't laugh. It's because each instance on a machine doesn't have to communicate with other machines, so we're fine. But yeah, I'm kind of going off. Go ahead. Next question. Go ahead.
So this is fairly freeform, right?
Yeah.
How does this affect what we heard in the previous talk in terms of what is the sparsity and pruning and things like that? Does this make things more complicated at the system level?
Yeah, so when you're dealing with these LSTMs we're using, the bidirectional LSTMs, the networks don't have a lot of sparsity. The convolutional neural networks will have thousands of neurons churning. You might have 5 or 6 activations as you go through that neural network word by word, right, per word. So this kind of sequence-to-sequence neural networks, especially on an LSTM, you don't have a lot of opportunities for pruning and no dropout and so forth.
So in your end-to-end system, how much does it differ from DeepSpeech and the CPC-4 that's a part of that system?
Yeah, so we don't do, how does, I'm sorry. So how does the system differ kind of fundamentally from systems like DeepSpeech and so forth? So DeepSpeech, so we don't do the ASR, so speech recognition going from the audio to text. That's pretty much commoditized these days. We use Google. In the example I showed, we use a Google API. We've also integrated into Nuance, into IBM, into Alexa, into Lex, Lambda, whichever marketing term it is these days. So we take the text and we do all of the AI, the analytics on the transactional data and the text. From a model perspective, the models that we're using, we don't use a hidden Markov model. We use bidirectional LSTMs for most of the work in the system. The offloaded, the training of the word embeddings, that's done once, right? So we have a 6 billion word corpus, and it's a unsupervised training model where you use n-grams to match words and the surrounding words to reason about how similar words are and where they should map to in that multidimensional space. So that happens once, and then we have pretty small neural networks for the language tasks that we then train with corpuses of 1,000, 2,000 utterances per per nugget of knowledge you want to train, per intent or competency.
The previous talk we heard a lot about hardware.
Yeah.
And in fact, Bill mentioned that like hardware is gaining the performance of machine learning and ability
Right.
to develop things. It seems like your talk has been mostly about sort of an
Application.
to use it.
Right.
So I was wondering, have you evaluated hardware at all? Like, do you feel limited by hardware? And I saw you had the collaboration with Intel. Do you think like CPUs are better than GPUs in some ways? Or
Right. Well, I'll tell. Phenomenal question. So, when it comes to this workload, this language understanding challenge, it turns out that 50% on an inference query, around 50% of the time is spent in a neural network, right? The other 50% is spent in Python and other languages. I think one of the huge insights that has come from this journey, as it's relevant to architectural implications, is you may want to keep around some of the beefy processor stuff when you're scaling to millions of inference type queries after you've trained that neural network architecture. When it's deployed, it turns out that a lot of cycles are not the kind of cycles that are ideal on a GPU. However, if you have some kind of GPU integrated with your beefy processor, then you might be able to get a balance that's just right when it comes to the inference work. Our training isn't that bad. So it turns out that training these language models that we're training, we can train that entire system in a couple hours. We do use GPUs for that. Titan X, we have about 8 Titan X's that we use to train up all of the models in this approach. When it comes to architectural implications, we've actually been working very much on the research side with Lucida and Sirius on sharing of GPUs non-preemptive accelerators and how you can guarantee quality of service objectives. It turns out that these non-preemptive accelerators, although GPUs are becoming more and more preemptible every year, presents new challenges when delivering on quality of service objectives. And we have a paper at ISCA this year, Power Chief, that investigates some of those issues. So, yeah. Sarita?
So you spend about 50% of the time on Python.
Yeah.
So how do you speed it up?
Right. No, that's the speed up version, actually. So it was like 90, right? Because here's the thing with a startup, and this is a very important insight. We've been designing and optimizing for the Googles of the world and for the big companies a lot. And it turns out that the tail in companies are smaller companies that use managed language, that use a lot of Python, that their development team isn't the most aware of how to optimize code. That question, how you speed it up, is informing a thrust of research that we're doing in the lab right now. How do you reason about the design of future processors, assuming that there's a lot of work to be done in that Python, in that managed dynamic language. And so I think it's a really, really good fodder for research. I'm always surprised we don't have more papers on accelerating Python in ISCA. It's all deep learning right now. So it's a good question. Thanks. Yeah. 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 Oh yeah, absolutely. So you're absolutely right. I mean, right now on the research side, we have a project with Ford. Oh, the question was, I mentioned automotive, and there's a lot of unique challenges in automotive, autonomous driving systems, let's say, that constraints on power and deadlines. It's a real-time environment. So, what are our thoughts on that stuff? And so, we're actually actively working with Ford right now, integrating Lucida into a vehicle so you can talk to your autonomous driving system. I've actually had some conversation with human factors folks, like what is the reaction time of a human being? when they see something or when they're turning and so forth. And these factors have to inform the system design end to end. And so you want to make sure you can do things faster than a human or just as fast. So it's also surprising how unregulated autonomous driving is. Like, we've done some research to figure out what are the rules, the design targets. And it turns out that the rules, there's a great quote, but it says something like, you know, when designing these vehicles, you should make best efforts to not brake. That was the extent of the government-sanctioned regulation. So it is a Wild West out there, but we've got some very smart people in the transportation research domains that are working on this feverishly. But good question.